Good morning, everyone. Welcome to the class. And today class will discuss binomial distribution. So whenever we talk about theoretical description of data, so when we talk about theoretical description of data, so it is very important to describe a data either as a discrete data or a data can be in continuous data. So we have discussed about what is data, what is primary data, what is secondary data, how we can get a data. Statistics is all about working on data only. And theoretically, when we are trying to describe a data, so data can either belong to discrete distribution pattern or either they belong to continuous distribution pattern. So when we have a data with discrete distribution pattern, they can be binomial distribution or they can be Poisson distribution. While when we talk about continuous distribution pattern, we have normal distribution, chi-square distribution, F distribution. There are different forms of distributions are there. So right now in today's class, we'll discuss about probably the form of distribution which is totally based on probability, which is based on random experiment, and the person who is being credited for doing a remarkable work in understanding the random form of data is basically James Bernoulli. So binomial distribution is basically it is a discrete distribution pattern that applies in a situation where there are fixed number of repeated trials in an experiment under the identical condition for which only one of the two mutually outcome, either success or failure, can result in each trial. So basically, when we talked about binomial distribution, so binomial distribution basically means a random experiment which is based on fixed number of trials, which can be done for fixed number of times, where each time when we do experiment, we either get a success or we either get a failure. Okay, and the probability of outcome is same for each trial. Okay, so and while the outcome what we get, that is independent from one trial to another. It means that outcome of one trial does not affect the outcome of other trial. So these things we need to understand. Then talking about mean, remember the formula mean under the binomial distribution. The formula for mean is n into p. The formula of variance is n into p into q, while the formula of standard deviation will be under root of n into p into q. You need to understand that the binomial distribution is a biparametric distribution pattern which have two parameters n and p. Okay, so this point you need to remember the maximum variance what you get in a binomial distribution you'll get when your probability p or q is equal to zero point 0.5. Minimum variance you'll get when you p is 0 or 1. Remember this thing. You always remember your mean in the case of binomial distribution will be more than your variance. Okay, so this part clear everyone. So based on this, you can solve the question. See the question number one. See the question number one. Try to solve this question. Question number one, everyone. This is the formula. Remember this formula. Based on this, solve this question. Everyone, can you do this question number one? N is given to you 48. Probability of recovery is 0.75. This I can write as 3 by 4. So probability of not recovery will be 0.25 or 1 by 4. So what would be the standard deviation? Under root of n into p into q. Under root of n is 48, p is 3 by 4, q is 1 by 4. This is under root of 3 into 3, the standard deviation. Any doubt anyone? Anyone, any doubt? Anyone doubt with this? Clear, everyone? Try this question number 2. Question number 2. If a probability that the marksman will hit the target is 1 by 5, the probability that he will hit the target is 1 by 5. So the probability that he will not hit his target, that will be 4 by 5. The probability of at least one hit in the 10 shots. Similar kind of question you have done already. One hit at least in 10 shots. So means you know that, right? 10 shot if he made, so means what would be the total sum of probability? Very well. The total sum of probability that will be equal to 1. So probability of at least one hit. The probability of at least one hit. Probability of at least one hit, that would be 1 minus probability of zero hit, that would be 1 minus. Okay, zero hit means none of the shot hit the target. If none of the shot hit the target, none of the shot hit the target. So you can understand like this. None of the shot hit the target. None of the shot, all the 10 shot will he miss. That will give you, so 1 minus not hitting, the probability is 4 by 5 to the power 10. Clear, everyone? Anyone, any doubt? Anyone, any doubt? Third one, see the third one. The mean and the variance of a binomial distribution are 4 and 2. The probability of 2 success is the mean and the variance of a binomial distribution. The mean is means n into p is 4 and variance n into p into q is 2. Okay, so if I divide this equation, second equation by first equation, I'll get np by np q is equal to 4 by 2. So I get 1 by q is equal to 2. So I'll get q is equal to 1 by 2. So p equal to 1 by 2. Okay, the probability of 2 success. So what is n? So you know that n into p is 4. If, if p is 1 by 2, so the value of n will be equal to 8. So once you understood this, so what is the probability of 2 success? So what is the probability of 2 success? N is 8, and if n is 8 and the probability of 2 success is the question, probability of getting success and probability of getting failure is 1 by 2. 1 by 2. So what is the probability of getting success? The probability of getting success is equal to a to 1 by 2 to the power 2 into 1 by 2 to the power 6. You're getting it, right? Probability of 2 success means 6 failures. So 8 trials we are doing. So you remember this binomial distribution and all. Remember, guys, binomial distribution, whenever we work on probability scenario binomial distribution, that this is the formula for that. This is the probability formula. P is the probability of success. Q is the probability of failure. The same formula which I told you for the repeated trial. The same formula we use here. So you just 8C2 means 28, right? 8C2 means 28 by 2 to the power 8. 28 by 256. You can simplify. This is 7 by 64. That is your answer. Anyone, any doubt? Any doubt, anyone? Any doubt, anyone? Clear, right, everyone? Then the next question. Do you want to try this question number 4? Guys, try this question number 4. Question number 4. In a binomial distribution with 6 independent tile, your n is equal to 6. The probability of 3 success and 4 success. 3 success means you understanding. So n is 6. Probability of 3 success and 4 success are given to you. The probability of getting 3 success would be 6C3 e to the power 3, and q, in place of q I can write 1 minus to the power 3. I hope you understood. This is given to you 0.2457. And then probability of 4 success, that will be 6C4 e to the power 4 into minus 2 to the power 2. That is given to you is 0.0819. Clear, everyone? You have to find the value of p here. So this will be your equation. This will be equation 1. This will be your equation 2. You need to solve this equation. You need to solve this equation, guys. So If you talk me to solve this equation, so this is 6c3 e to the power 3 into 1 minus p to the power 3 divided by 6c4 e to the power 4 into 1 minus p to the power 2, that is of 2457 divided by point 08. So this 63 is 20 and 64 is 15. Okay, so this is 1 by p. This is 1 minus p. Okay. This is 0.2457 divided by 0.0819. Okay, everyone. So this would be 4 by 3. This would be 4 by 3. So this I can write 1 minus p divided by p is equal to 3 by 4 into 0.2457 divided by 0.0819. Okay, I'll use calculator for this. Okay, I'll use calculator for this. So I'll try to find this value. So 3 by 4 I can write as 0.75, right? 3 by 4 I can write as 0.75. 3 by 4 I can write as 0.75 into 0.2457. 0.457 divided by 0.0819. 2.25. 2.25 is 9 by 4. Can you understand? 2.25 you got. This total you got 2.25. Yeah. Total you got is 2.25. 2.25 is nothing but 9 by 4. That is nothing but 9 by 4. So if I solve this, 4 minus 4p is equal to 9p. So 4 is equal to 30. P is equal to 4 by 30. E is equal to 4 by 30. Get the value of P is equal to 4 by 30. Any doubt, anyone? See this, ask me if you have any doubt. See the calculation, guys. Ask me if you have any doubt. Clear, everyone? I hope everyone understood this. So then next one, the mean and the variance of a random variable having binomial distribution are 4 and 2 respectively. Find x greater than 6. I think we have done this kind of question. Mean is 4 and the variance is 2, right? So I think we did n we got 8 and p and q we get 1 by 2, 1 by 2. So if I divide np by npq is 4 by 2. So we get 1 by q is equal to 2. So I get q is equal to 1 by 2. So the p also I'll get is 1 by 2. Okay, so then n into p is equal to 4. So n into 1 by 2 is equal to 4. N is equal to 8. So your n is equal to 8. Your p and q is equal to 1 by 2, 1 by 2. So for the r value greater than 6, that will be probability of 7 outcome plus 8 outcome. Total n is 8, right? So the total set of outcome will be from P0, P1, P2 till P8. The total sum will be equal to 1. So P7 will be, what would be the P7? That would be 8C7, 1 by 2 to the power. Success is also 1 by 2, failure is also 1 by 2 to the power 8. I hope you understand. 8C8 into 1 by 2 to the power 8. So that will be your answer. I hope you are getting the logic. So then this would be 8C7 plus 8C8 divided by 2 to the power 8. 8C7 is 8. 8C8 is 1 divided by 2 to the power 8 means 256. 9 by 256. That is your answer. Clear, no, everyone? Everyone getting the concept, right? Anyone, any doubt? Anyone, any doubt? You can see this. Yeah, you can see this. Question number 6. Guys, see this question number 6. Tell me the answer for this. Question number 6. What would be the answer? Question number 6, guys. Tell me the answer for this. So the question number 6, the probability that a pen manufactured by the company will be defective, that is 1 by 10. So the probability of the pen manufactured by the company is defective. So defective probability is 1 by 10. So the probability of non-defective, that would be 9 by 10. Defective is 1 by 10. Non-defective would be 9 by 10. If 12 such pens are manufactured, so n is 12. If 12 such pens are manufactured, so n is 12. Okay. Then, then using binomial distribution, find the probability that exactly 2 will be defective. Exactly 2 will be defective. Probability that exactly 2 will be defective. So that will be nothing but NCR p to the power r p to the power n minus r. So you can understand here what is P. P is the probability of success. So what is the probability of success here? That the pen what you get is defective. Failure, that the pen what you get is non-defective. So this would be 12 C2 is 1 by 10 to the power 2, 9 by 10 to the power 10. This 12 C2 is how much? 12 into 11 by 2. 11 6 is 66 into 9 to the power 10 divided by 10 to the power 12. This is your answer. Clear, everyone? So if you have calculator and all, log table calculator, you can find this value. Now what is 9 to the power 10? 9 to the power 10, one thing I know, it will end with 1. That only I'm sure about. Rest I'm not an idea. Okay, so this is the first one. Second one is exactly 2 will defective. At least 3 will be defective. At least 3 will be defective. So if I say probability that at least 3 defective, at least 3 defective, at least 3 defective, you know that, right? P0 plus P1 plus P2 plus P3 plus P4 plus P5 plus P6 plus P7 plus P8 plus P9 plus P10 plus P11 plus P12. That total sum will be equal to 1. You know that, right? So P0 plus P1 plus P2 plus P3 till P12, that will be equal to 1. I want at least 3 defective. I want at least 3 defective. So you can understand. So at least 3 defective, at least 3 defective, at least 3 defective. That is nothing but 1 minus none are defective plus 1 is defective plus 2 is defective. I hope you are getting this concept. So at least 3 is defective. So this is 1 minus 12C0 into 9 by 10 to the power 12 plus 12C1 into 1 by 10, 9 by 10 to the power 11 plus 12C2 into 1 by 10 to the power 2 into 9 by 10 to the power 10. Just need to solve this. So you need to solve this. So 1 minus 12C0 means 1. And this is 9 by 10 to the power 12. So 12 into 9 to the power 11 by 10 to the power 12 plus 12C2 is 66, right? 66 into 9 to the power 10 by 10 to the power 12. So you can solve this 1 minus, I can take 9 to the power 10 common, 10 to the power 12 common. So I left with 1 plus 12 into 9. Okay. 1 is 1 minus 9 to the power 12 by 10 to the power. Denominator is same only. Denominator is same only. 12 to 9 to the power 11. The 66 into 9 to the power 10. Denominator is same only. So I can write this as 1 minus. So 1 minus 9 to the power 10 by 10 to the power 12. This is 1 plus 12 into 9 plus 66. This is 1 minus, this is 9, 12 nines are 108, right? Plus 67, 175. 175 into 9 to the power 10 by 10 to the power 2. This is your final answer. This is your final answer. Clear, everyone? Okay, almost 3 are defective. So you get at least 3 defective, right? So almost 3 are defective. Almost 3 are defective means almost 3 are defective means almost probability that almost 3 are defective. Almost 3 defective. Not at most, no, not almost. At most 3 defective. Most 3 defective means P0 plus P1 plus P2 plus P3. Most 3 are defective. Are you getting this way? At most 3 are defective means P0 plus P1 plus P2 plus P3. So P0 is 12C0, 12C0 and 10 12C0 into 9 by 10 to the power 12 plus 12C1 into 1 by 10 into 9 by 10 to the power 11. So this is 12C2 into 1 by 10 to the power 2 into 9 by 10 to the power 10 plus 12C3 into 1 by 10 to the power 3 into 9 by 10 to the power 9. That's it. So, yeah. So this will be 9 by 10 to the power 9 is 12C0, 9 by 10 to the power 3 plus this is 12C1 into 1 by 10 into 9 by 10 to the power 2 plus 12C2 1 by 10 to the power 2 into 9 by 10 plus 12C3 1 by 10 to the power 3. That's it. I need to solve this. This is 9 by 10 to the power 9. This is 1. 9 by 10 to 12 into 9 square by 10 to the power 3 plus this is 66 into 1 this is 10 to the power 3 plus this is 12C3 means 12 into 11 into 10 divided by 6. 12C3, this is 220, right? 20, 220 by 10 to the power 3. This is your answer. This is 9 by 10 to the power 9. This is 9 cube plus 9 cube means 729. 729 plus 12 into 81 plus 66, 54, 5 carry, 594 plus 220 by 1000. And solve this. You can solve this. This will be equal to 12 into 81 means 12, 96, 972 plus 729 plus 594 plus 220. So this 9 plus 6, 15, 1 carry. 1 carry means 1 carry, 10, 12, 14, 21, 2 carry, 11, 18, 20, 25, 2515. 2515 into 9 to the power 9 divide by 10 to the power 2. Final answer. Clear, everyone? Any doubt? So this came for 10 marks. Yeah. Done, everyone? Any doubt, anyone? Any doubt? You understand, no? The term at most, at least. All these terms you are clear, right? And now see the next question. So fit a binomial distribution to the following data. See this question number 6. Fit a binomial distribution to the following data. So you are given certain values of x and f. You are given some values of x, some value of f. 0, 0, 1, 2, 3, 4. This is 28, 62. This is 46. This is 10. This is 4. So what you need to do, on you have to make construct a binomial distribution table based on this data. So you know that, right? Whenever we talk about binomial distribution, you know that in case of binomial distribution, you know that in case of binomial distribution, you know that in case of binomial distribution, in case of binomial distribution, you know that your mean is equal to n into p. Okay. The formula of mean we can find as sum of fx by sum of f, right? So we can find the mean by that formula. So here the sum of fx, sum of f is 28 plus 62. This is so 6 plus 2, 8, 9, 90, 100. This is 150. This is sum of f. Then f into x. This is 0. Then this is 62. Then this is 92. Then this is 30. And then this is 16. So sum of fx is equal to 2 plus 2, 4. Then 1 carry. 1 carry means 16, 19, 20, 200. So the mean, if you see your mean sum of fx by sum of f is equal to 200 by 150 is equal to 4 by 3. Okay. Your mean is equal to 4 by 3, guys. So your mean is equal to 4 by 3. By looking at this data, you can know, right, what is n here? N is equal to 4, right? Total data is 4, right? Any doubt with that part? You understanding, right? N is equal to 4, right? So you have 4 set. So the probability would be probability of getting 0 plus 1 plus 2 plus 3 plus 4. So you know that n into p. So n is 4 here. So 4 into p. Mean you got is 4 by 3. So the probability of success is 1 by 3. So your probability of failure, that is equal to 1 by p, that would be equal to 2 by 3. Clear, right? So you get p and r value. So you can easily find the value of px. Probability distribution you can find, right? P into x. What is p into x? This would be, what is n here? N is 4, right? N is 4, right? So this would be pc0, 1 by 3. Success is 3. And failure is 2 by 3, right? 2 by 3 to the power 4. So this will be equal to 16 by 81. This probability, that would be 16 by 81. This probability, this would be 4c1, 1 by 3 to the power 1, 2 by 3 to the power 3. C1 is 4 into 2 to the power 3, 8 divided by 81. This would be 32 by 81. Similarly, this would be 4c2 into 1 by 3 to the power 2, 2 by 3 to the power 2. 4c2 is 6, 6 into 4. 6 into 4, 24 by 81. And 4c3, 1 by 3 to the power 3 into 2 by 3. That is 4 to the 8, 8 by 81. This is 4c4, 1 by 3 to the power 4 and 2 by 3 to the power 0. That would be 1 by 81. So you'll get the probability distribution, right? In binomial distribution, you know the probability distribution formula. You remember last chapter we learned that only. Last chapter, probably the last class, what we are doing, mean and variance of a random variable. So here in that random variable, we are talking about binomial distribution, such set of variable which follow binomial distribution. So you can, once you get the probability distribution, so what you can do, once you get the probability distribution, guys, so what I can do, guys, what I can do once I get the probability distribution, I can find the expected binomial frequency. I can expected binomial frequency. So what is their expected binomial frequency? Once you get their probability distribution, guys, once you get their probability distribution, what I can do, I can find their expected binomial frequency. I can find the expected binomial frequency. So how will I find their expected binomial frequency? So the expected binomial frequency for that. just apply the formula, that is n into probability distribution. N into n is 150. N is 150, right? N is 150, right? So n is 150. 150 into the probability distribution by 81. So this 150 into 16 by 81. 150. 15 into 16. 15 is 225. 15 square. So 225 plus 15. That this would be 2400 by 81. Okay, this would be 150 32 by 81. I'm doing so this. So this you can cancel this. This you can cancel. This would be 800 by 27. You can find this value. And this similarly you can do this. 150 you can write this as 50 by 27. And then 32 fives are is 1600. Divide by 2, no, 1600 by 21. 1600 by 27. You can do that. This is 150 into 24 by 81 by 27. This is this would be 1200 by 27. So this is 150 into 8 by 81. This is 50 by 27. So this is 4400 by 27. And then this is 150 into 1 by 81. So this is 50 by 27. So these are the probability distribution. Okay, so we can find the values. We can find the value 800 by 27. 800 by 27. That is 29.62 something. You can write approximately 30. Approximately you can write. So this would be approx 60. 59 or 60 approx. Similarly, 1200 by 27. By 27, that would be 54 point. You could have written 400 by 9. 44.44, not 44 approx. And this is 400. 400 by 27. 400 by 27. 14, 15 you can write approx. 15 approx. This is 50 by 27. That is 1 point something. Right. So these are the values you get. These are the values you get. So I can write hence the fitted binomial distribution. The fitted binomial distribution is F0, 1, 2, 3, and 4. That is equal to 30, 30, 59, 44. 30, 59, 44, 15, and 2. This is the answer. Clear, everyone? Anyone, any doubt? Clear, right? Any doubt, anyone? So if you get time, you can solve other problems like this. you get time, you can solve other problem like this. Just like this question number 5 is similar to what we did the previous question. So there also probability of defective was 1 by 10, and there also the n was 12. You can do this. Question number 5 is very similar to what we did already. So guys, this much we'll do. So this much I have planned to discuss in the binomial distribution. So I hope you understood everything whatever I have done so far in this class. With this, I'll end this class. Thank you everyone. I'll see you all tomorrow. Take care. Bye everyone.